Section 7.5, we're looking at properties of trapezoids and kites. Our essential question, what are the properties of trapezoids and kites? So first thing, we'll look at trapezoids first. First thing we do is define a trapezoid. Trapezoid is a quadrilateral with one pair of parallel sides. You look here, we have things labeled. So your parallel sides are called the bases. Your other two sides are called the legs. One of the things to watch is that your base does not have to be the bottom. So we look at a shape like this, right? These two sides here going up are parallel, so they would be bases. So your base is not always the bottom, the base is the sides that are parallel. We'll also, as we're going through, talk sometimes about base angles. Base angles are angles that share a base. So A and D is one pair of base angles. B and C is another pair of base angles. We also have then isosceles trapezoids. Isosceles trapezoids give us more stuff that we can solve. Isosceles trapezoids are trapezoids with congruent legs. So when we look at the picture, we see that A, B, and C, D are marked congruent. So we have, and BC and AD are marked parallel. So A, B, and CD, the legs are congruent. So we have an isosceles trapezoid. If we have an isosceles trapezoid, one of the things we know is that base angles are congruent. This lets us do more when we're solid, right? Because we can go back and forth. So we're looking at our examples here, solving for parts in our trapezoid. Example 1. They're asking us to find the missing angles. So here we have 76 and 123. I don't have anything marking these sides as here as congruent, so it's not isosceles. That means this doesn't help me over here. So basically I'm looking at two separate problems here. Because these are parallel, these angles here are consecutive interior angles, meaning they have to add up to 180. So I'm doing 180 minus 76. It's going to be 104. Over here, the same thing can be true. These two are consecutive interior angles, so they add up to 180. So do 180 minus 123. So that gives me 57. So this angle then is 57, and this angle then is 104. On B, we have the sides marked congruent. That means our base angles are congruent. So that makes my life a little bit easier. For N, I know that is 50. And L and M are also going to be the same. So again, I'm going to do 180 minus 50, because these two are consecutive interior angles. That gets me 130. That is both angle L and angle M. C, again, they give me an isosceles trapezoid. So if this is 135, C is 135. Subtract from 180, I get this angle is 45, and this angle that went off the paper would also be 45. Example 2. All right, they want me to show that CDEF is a trapezoid. So first thing I want to show that one pair of sides is parallel. Easiest way to show parallel is looking at our slope. So if I look at DE and CF, those are the two I would expect to be parallel. Go up 1 over 3. Here I come up 2 and over 6, which reduces to 1 over 3. So these are parallel because they have a slope of 1 to 3, or 1/3. Then I look at DC and EF. Right here I'm coming up 1, 2, 3, and over 1. So I have a slope of 3 to 1. And when they're going in different directions, so this should be easy to see as well. But here I go up 2 over 2. So this has a slope of -1 because of the -2 there. So 2 over -2. So then these are not parallel. That would be showing that would be enough information to show that that is a trapezoid. If they asked me to show that it was isosceles trapezoid, I would then have to show something about length. But here, we're just good showing our slope. And then turning our paper over, what we're looking at there is the trapezoid mid-segment theorem. This says the mid-segment of a trapezoid is parallel to each base, and the length is half the sum of the lengths of the base. So here, MN is connecting the midpoints of those sides, right, which I don't think they don't tell me that that would be my definition of a mid-segment, that it connects the midpoints on the sides. We didn't have the definition, we don't have the definition on here. This is our theorem. So this is connecting midpoints, so these parts are equal, these parts are equal, not necessarily going that way unless it's isosceles trapezoid. So it's parallel to the other two sides, so I can do similar things. I can do corresponding angles, we can do consecutive interior angles. It also tells me it's half the sum of the length of the bases. So MN equals 1/2 AB plus DC. We could also write that, which is sometimes easier, AB plus DC over 2. So we look at example 3. They tell me this is 16 and this is 9. So I do 16 plus 9 over 2, which gets me 12.5. We're looking here. We have 30 and 12. So do 30 plus 12 over 2, which will equal 21. An interesting thing here that's sometimes helpful, especially if you have parts and not both sides, is the change is always going to be consistent. So if I look here, 9 to 12.5, I'm going up by 3.5. Then add another 3.5, I get to 16. Here if I go from start at 30, if I subtract 9, I have 21. If I subtract 9, I have 12. The change is always going to be different depending on your numbers, but your mid-segment, the change from one to the other, will always be consistent. So if I know that my mid-segment is 12, or if my side is 12, if I told you this was 20, you can say, okay, I'm adding 8, that means this has to be 28. And that always works. Then we're moving on to kites. A kite is a quadrilateral with 2 pairs of consecutive sides. Don't have much room here. With 2 pairs of consecutive sides that are congruent. But opposite sides are not congruent. the opposite sides not being congruent basically keeps us from identifying the square as a kite. Some properties of the kites. The diagonals are perpendicular, which we see here. Right. I'm going to list these here in the middle here. Diagonals are perpendicular. Which again means they meet at 90 degrees. We see that right here. You have one pair of congruent angles. Okay. That pair will always be in between the non-congruent sides. So like C and A are congruent on this picture, right? And I know that one because they're marked, but also because they're in between the non-congruent sides. So looking at some examples here. Example 4 asks us to find the missing angles. So F and H are congruent because they're the angles in between the non-congruent sides. So F is 110 and my shape adds up to 360. So if I do 110 plus 110 plus 60, take that away from the 360, you get that angle G is 80. Yeah. QRST is a kite. Now here they give me 70 and 88. So these two are not equal. These two are equal. So when I do 70 plus 88, and my 158, I take that away from 360. Get 202. Divide that by 2 for each of these, and both these angles would be 101. And then example 5. This square got cut off by our hole punch here. They're asking us to find the side lengths. The side lengths here, these are meet at 90. So we'll do the one to show it. This would be Pythagorean theorem, which you've mentioned before. So I have sides of 10 and 19. So I have 10 squared plus 19 squared equal to WX squared. So first thing I want to do is my squaring. So 10 squared is 100. 19 squared is 361. So I have 461 equals WX squared. So I take the square root of both of that number there and gets that WX is 21.47 is my length for WX. And it's cut off so we won't show the other one, but the other side I would use 10 and whatever I have here and then do the same thing to get XY. And that would give me all my sides because the consecutive sides are congruent. So WX, WZ would be congruent, XY, and YZ would be congruent.